All right, I'm back. Nice to see you, wenlong.
Yeah,
How are
thank you
you?
for doing this interview with me. It was like, yeah, thank you so much.
Thank you.
Uh,
So,
so, uh,
yeah, go
to,
ahead.
yeah,
Go
to
ahead.
start off, well, welcome and thank you for doing this interview. So please, tell us a bit about yourself, like, in general, and then maybe a bit more specific on like, your experience with like software projects and
Uh,
projects you've been working on.
okay, long story short, because I have been working on the software industry for almost 30 years. Well, that's very long. So I just try to put everything together short as possible. I'm Canadian as well. I'm not sure you know that or not. I'm Canadian, but currently I'm in California, in Silicon Valley. Well, I started in China for about in 1943. Oh,
Mhm.
sorry, 1993, not 43. I cannot leave that. Sorry, 1993, and started the software. I did a lot of projects. I cannot list them all because it's history too long. But right now, recent years, I was working on like a blockchain or decentralization projects. So that's a kind of new shining star in the industry. So I'm working on that at this moment. And then before that, I was CTO of a company, a startup company in Silicon Valley called iHealth, and that is a company who makes the like smaller wearable devices. You actually can wear it on your arm. You can test the blood pressure or like heart rate monitor. That is company doing this kind of stuff. I was the CTO of the company. I make the software platform to monitoring the health status for our clients. We have a cloud services like something. And then before that, I was working in some large company, like many of them. I cannot list them all. So yeah, I've been working about 30 years, so I can I can see the different trends of the software, starting from like a DOS, DOS. Probably it's too old. Probably you don't know that. Starting from the DOS era and the Windows and the Unix, Linux, cloud computing. Right now, the decentralization. That's yeah, I can see a different trend. And regarding the software, like the programming languages, starting from C, of course. A lot of people like me starting from C, C++, C Sharp, Java, Ruby, JavaScript, and now I use Rust right now. Rust is my main language at this moment.
What's it called?
Rust, Rust, R-U-S-T.
All right,
Yeah,
nice.
it's a kind of newer language, but it's very popular in the distributed system. If you like system level, could be a replacement of the C language.
All right, that's cool.
Yeah,
Yeah, I don't really like C so much. Like,
but
I
you
like,
will know.
uh,
Like,
yeah.
you will know.
Okay. So, yep. So I guess tell me a bit about like what you're doing right now, or like a specific project you that's really memorable to you, like and like what company that was for and what you guys did.
Oh yeah, yeah. Actually, this is not a company. I have to say because you can see the company is one way of people work together. It's not the only one. It's popular. I know 99% of people working in a company, but right now the trend is starting to change. So there are a lot of new teams, new groups of people like what I'm working on. I'm working on startup, but not a company. It's an organization. So people are working on this. We call it open source project. So people working like voluntarily in this kind of project and contribute the code into it, but it's not a company.
Yeah.
We don't get paid. I don't get paid either. It's kind of organization. So what we do is we actually looking for the early stage research on the next cloud computing. Why I say it's a next? Because right now the cloud computing is still centralized. And the word centralized, what I mean is, for example, you have your code, you're gonna deploy to say Amazon, Google.
Right.
That is central, right? You give a code to a data center running in Amazon data center or Google data center. That's a center. So what if like the center is break down, something wrong in the center, or network connection is totally down? Your code will not run, right? This is called centralization. So that's like a single point of attack. But the we are working on is called a decentralization. That there's no single point of failure. So you deploy your code, you deploy your data. the data will go to no one know where it is. Like a lot of nodes, like a peer-to-peer, right? You know peer-to-peer, right? P2P.
Yeah.
It's P2P. Like it could be deployed anywhere, and there could be thousands, maybe 10,000 of nodes running a host of your data or code. Now, when you have a task to run this function, the code could be running in one of them or three of them. You don't know. Actually, nobody knows, and you can get result from somewhere you don't know, because it's randomness, and also because no one can control it. You want to turn on, like turn off few of the nodes. Doesn't matter, because we have thousands of nodes running at the same time. You can turn on maybe 500 of them. Doesn't matter. We don't really care, and no one know actually, because it's a very robust. That's the main reason why we do things decentralized. So this is actually the technology, the blockchain, and the Bitcoin is using as on the layer. So the decentralization or distributed system. So we are working on this. I think this will be a new trend of the future cloud computing. I believe in the future, people probably don't really need the data center. We just deploy the nodes to wherever we call the edge computing. And edge computing means the server is not in the data center. It's somewhere close to you. For example, like a 5G base, the wireless communication, the 5G, and maybe in the future 6G, there will be a lot of a tower close to you. The broadcast signal, the 5G signal. There could be a lot of server over there, not in the data center, because the transfer data to the data center is too long, too slow, and people just deploy the node like close to you, so your data can be processed there. So this is what we are working on. The project has a name called TEA, just like the tea I'm drinking.
Nice.
The TEA stands for T stands for trust, trusted, and E stands for execution, and A stands for attestation. So put them together is a T. It means trusted, execution, and attestation. That means you can trust. You don't have to trust a node to run your code, because the system and the algorithm can protect your data, your code from steal by other people. Right. That's why we call it trusted execution and attestation. That's how the name comes from.
Yeah. So
go ahead.
So for this project, so basically you guys are like the front runners. Like there's not really much like stuff to base it off of. Like
yeah. We are always front runner, because we are in Silicon Valley, which is a center of the innovation. Nice. It's especially for me, my personality tell me to don't follow up what other people do. We always do something new, and no one try to be before. But we actually think it will be the future. Then we just get into it, and we like doing this kind of new stuff. Pretty cool.
Pretty cool. Yeah. So that aspect of your personality, like really drives you to like work on like these types of projects versus like more conventional ones where like everyone's doing it, so like we are gonna do it too, like that kind of stuff.
Yeah, that's true.
Yeah. So like, did you ever like work on like more conventional like projects versus like these kinds, or like
was it conventional, like the traditional project?
Like I mean, like basically like what everyone else is doing, like versus.
Oh yeah, I did before. For example, my previous job, the CTO of the iHealth, that is kind of a traditional job. CTO, it's a company, have like 1,000 of people, then manage all the engineers. And the product is it's still kind of innovation, like wearable devices. It's still an innovation, and also using the internet to keep people healthy. That's also a kind of innovation. But the technology-wise, it's not I cannot tell it's a really very, very new innovation. It just use the existing technology, just utilize the technology in the healthcare industry.
All right.
Even so, we still use a lot of modern technology at that moment.
Yeah.
For example, full stack development. Full stack means the front end, back end to get together. So because we don't have a lot of engineer, it's so expensive to hire engineer in Silicon Valley. So that's why we try to hire as less as possible, and to make them very productive. And in order to do that, we have to use a modern technology. So everything, if we can do it more automatically, we do it automatically. We just use the engineer to do like the things cannot be done by the machine, have to be done by the people. So we hired I cannot say it's a high end, but it's pretty good developer. And we use modern technology, full stack, and everything automatic. So we can have a very few engineers. We did a pretty cool job.
Okay.
Cool project.
So like working on something like that versus like this open source project you're working on right now, like what are like stuff that are like completely different, like something that you would need to consider? Like so like they're obviously different, right? Like
very, very different. So the biggest one I can tell is because we don't get paid. That's very different. So as a company, you pay some people to work on you. So it doesn't matter he likes it or doesn't like it, or he agree or didn't agree. Doesn't matter because we paid you, right? You have to work out what we request. Then we pay you. So it's kind of we can see it's an exchange. But in the open source project, it's very different since people didn't get paid. The only thing you can motivate the people to do this stuff is he really like it. He even want to spend the time he used to spend the time to make money, but they didn't make money. They work for you.
Yeah.
That's really totally because he really like it. And also, your project has to be like very cutting edge. Like has to be in the leading edge. And the people say, "Oh, this is the future. I really want to do it." Especially for younger developers, they still in the learning stage. So they really want to try to use something new.
Yeah.
For example, the language I just mentioned, like Rust, R-U-S-T. I probably never heard about it, but you will. You will. Yeah. I believe you will. It's a new language, about 10 years old. A lot of developers, they know the advantage of this kind of new language. They want to looking for somewhere they can try to use it.
Mm-hmm.
Because it's very new. So not a lot of projects actually using the new language, using the new technology. So there are not a lot of choices. So we use the new language. So a lot of newer, younger developers, they want to try, I want to join the project. First, I believe what you say, what you're trying to do is the future. Second, I get a chance to learn the new languages, learn the new way of thinking, and learn the new tools. So they want to join us to work together. And also in the future, even so, right now, we probably don't have a business model. We just trying like new stuff.
Yep.
I believe in the future, there will be some monetize. There will be, but we don't know. We cannot tell yet. Just like, for example, 10 years ago, when Bitcoin was invented by Satoshi Nakamoto, he didn't know, I believe he doesn't know what it will be in the future after 10 years. He doesn't know one Bitcoin worth like $10,000 today. He doesn't know that. He didn't know that. I guess he didn't know that at that moment. But now we can see it's a big industry. Bitcoin is one of them. The Bitcoin is the basic, very, very basic, the blockchain. So what we are working on much more advanced than that. But it's just change. It's just if you are at the cutting edge, you can see the what's gonna be the next.
So like working on like an open source project, like how would you guys actually manage the whole workflow? Like obviously like everyone's gonna be like working from home and stuff, right? So like how do you make sure like there's no security risks, or like how does everything get put together? Like yeah, that kind of stuff. Yeah.
Okay, so GitHub is what we are using right now.
All right.
GitHub, GitHub, it's open source, host of almost millions of projects. So because it's open source, we don't have a lot of secret. Secret is the code. So we don't own the IP. So it doesn't matter who uses it because it's open source. And second, because it's everybody using their own like spare time work on it. So we have to get more people involved. And for example, there is a feature we're gonna use some people to work on this feature. We just listed on the GitHub, and some people who said he had time and he want to work on it, he can take his task and work on it and just submit the code to us. And we like the core team has the authorized to merge the code from the developer branch to our own branch. So we're going to review the code to make sure the code it don't introduce any kind of bug. There will be, but not we just review it, make sure it's a very few bugs. And also we can make sure they don't have a security flaw in it. And then we merge the code into the main branch. So that's why sometimes a feature can be done by several persons. They don't know each other. So it's kind of funny. We have to choose one of them, or we have to talk to them. Say, oh, how about we merge them together? You finish the first half of the feature, but another guy finished which is doing better for the second half. So probably we have to merge together to make the better version. Sometimes it happens.
Yeah.
But because open source, people work from all over the world. We actually sometimes we don't know each other. Even we know the ID because we talk a lot on the GitHub. But we actually never meet the person. I don't even know the person is where is in the United States or Canada or Europe or China. We don't know. We just we still work together. Sometimes we have a Zoom meeting like this, so we know, oh, this kind of lady. Sometimes we don't know it.
Yeah, that's really cool.
Mm-hmm.
So they can't actually push to GitHub directly. They'd have to submit it to you before it gets
the core team. Now they can submit directly to the main branch, but if you are not a core team member, you have to send called the PR, pull request.
Pull request.
Yeah, pull request. It's a terminology in the GitHub. So you make something in your own branch. So everybody can fork the project into your own branch. You make some modification that's committed to it. You test it, it works. Then you have to send a pull request, request the core team to pull your change to the main branch. So after we agree your pull request, then your code will become the main branch, so other people will. So this is GitHub work.
Yeah. What if the main branch changes before they submit the pull request?
Oh, they have to merge. They have to merge.
Oh,
for example, before you send the pull request, you have to pull from the main branch the latest change and compile or merge into your own branch, make sure it works. Okay. And then you give a pull request.
Okay. Yeah, that sounds good. Okay, and so for you personally, when you're trying to develop something new, are you more leaning towards, okay, so this is what I want to do. I want to make it as advanced as possible, or is it I want to make it as fast as possible, or would it be something more I want to make it really scalable, make it at some point become so big that it's accessible to?
At first, those three factors are all of them are very important.
Yeah.
But depends on the stage of the lifetime of the project.
Mm-hmm.
What I mean by the stage is at the early stage, at the growth stage, or stable stage, they have different requirement. So at the early stage, because you just, for example, in our current stage, which is kind of early stage in the T project, the most important thing for us is to do a POC. POC means a proof of concept. So we're gonna have make some prototype to verify what we're trying to do is usable. Right. So at this stage, we have to give up some of the factors. We have to consider in the stable stage, because the time limit, time constraint, and the different people may hands. So we have to give up something, and that we cannot give up is the main feature. For example, in our project, the main point of the project is first we have to be decentralized. So all the code has to be distributed all over the world, and the scalability is very important thing. So scalability is something we cannot give up at this moment, even at the early stage. But give you another example, it's a very opposite side. You're working on a small project, for example, you make a website, you're making a chatting program, making a fake WeChat or fake Facebook. So at this moment, probably the first thing you're gonna try is you have to have a very beautiful UI to attract users to use it. You have to give them a very good user experiences. But at this early stage, probably you don't really care about the scalability, because the key point is you have to be user-friendly. People like to use it. And when people engage to your product, then you can think to get to the second stage, growth stage. you're probably going to think, oh, what if I have a 1 million user tomorrow? You're going to handle it. So scalability is something you're going to consider later, not today. But for us, it's very different because for us, we actually don't have a UI at all. We don't have a user experience because we're not facing to the end user. We are an infrastructure. So we don't care if the user experience is so far. What we care most is one is security, because we kind of trust, right? Trust the execution. And second is the scalability. Is something we have to think from the first day. So that's why I'm saying, so different products, you have different main points. Then you focus on what you're going to do at the early stage, not all the same. And at the second stage, probably, like if you do a fake Facebook, you're probably going to think the scalability. But for us, because we already thought about the scalability at the first stage. The second stage, you probably going to focus on more on user security and user experiences. And so it's different, very different.
Yeah. Okay. Yeah, that makes sense.
Mm-hmm.
So like obviously like this project is pretty special, but like if it applies, like assuming like you want to add a lot of features to it, so like that you think are gonna be really helpful towards the goal, and so like would you do so in like a manner where you wanna just like see if it works out, and if it fails then you'll change it, but if it doesn't then you'll add like even more, so like add at a really fast pace different features versus like doing it in like a pace where you can test like extensively before you actually add any like kind of features?
It also depends. Let's say I'll give you two examples. One example is the fake Facebook. So that kind of software is very like a human interactive. So probably because human behavior is you cannot predict, right? You don't know what kind of user experiences people really like. So probably you're going to have to try a lot of different features. Sometimes you try it simultaneously, like A/B test. You're going to option A, option B, 50-50, right? You can see how people behavior, what the people respond on it. So in that case, in that kind of application, probably going to try a lot of different features and see, oh, doesn't work, we can change to a new one. Or you add a new feature to test. This is one kind of application. Another one is like something like we are working on, the T project. We clearly know what the feature we're working on, and not too many features, only one or two, but very hard. Like for example, one of the features is how do we know a computer owned by another guy? The result is trusted. It's very hard. It's kind of an easy question, but you cannot answer because the computer is in another guy's garage. I don't really know this guy. Probably is a hacker, right? We don't know, but do we trust him to send my data, like sensitive data, to this guy, and they make a computation and get a result back? What if he like steal the data and use my personal data to do some like weird things, or he just give me a wrong answer? I don't know. How do I attest it? So this is kind of an easy question, but it's very hard to get answer.
Yeah.
This kind of it's one feature, but people working on this feature for more than 30 years, I believe. I believe 30 years ago, people were thinking about that. How do we know the answer is correct? But still, till now, people still working on it. Like we are still working on it. How do we know the result is correct? There are a lot of algorithms doing this kind of stuff. We are one of them. So for this kind of feature, you don't have to try because it's very clear. We're gonna fix this, right? It's very clear. And we don't try different, but we will try. What we can try is a different way to solve the same problem. For example, some people using some very complex mathematical algorithm to do this kind of verification, and some people using the hardware, like some we call the enclave in the CPU, inside the CPU, to do this kind of stuff. But what we're going to do is we're using the technology we learned from the blockchain. We use the blockchain consensus and the kind of a technology or algorithm to deal with this kind of stuff. So people try different way. I cannot tell they are wrong or we are right. We don't know. But until the day we actually can solve the problem, we can say, oh, we are right. You're probably wrong. So that's we try different from different angle. It's still one feature, but we try different way. One of us we're gonna win. I hope we are.
Yeah. So like I think blockchain is like very central to like this project you're working on. Can you just like tell me a bit about how like what it is and like how you're actually using it?
Oh, regarding the blockchain, we don't consider we are blockchain. But we are very close related to blockchain. We consider in our industry the terminology of the layer 1 and layer 2. The layer 1 is the blockchain, like we call the other layer. And we are working on the layer 2, which is on top of the layer 1. Now we do something layer 1 cannot do. The blockchain is a very big topic. Probably we can spend like 3 hours talking about blockchain, so it's very hard. But I believe if you are interested, you can very easily Google search the blockchain and got tons of information and read it. Okay. Especially the first one you're gonna read is the white paper of the Bitcoin. The white paper is 12 years ago. A guy called Satoshi Nakamoto. It's a fake name. We don't really know this guy who this guy is, and is it a real one person or a group of person, or what's his real name? And some people even suspect this guy didn't expect at all, didn't exist at all. We don't know. So, but there is a white paper saying Bitcoin, a peer-to-peer digital currency, cryptocurrency. So that is to me, it's the first thing you're gonna read. So you're gonna know what blockchain is and why we can trust blockchain. Even like the question I just mentioned, a guy running very important computation, like make the ledger, like send money from one guy to another guy is very important, right? It's real money. It's not fake money. It's real money. It's very important. But even I don't own the nodes. I don't know the machine, but I still can trust that guy. Why I can trust? The Bitcoin give you a very clear answer. And since then, Bitcoin is running for more than 10 years, still very stable. Yeah. Consider you make something, for example, I make something 10 years ago, still running without even nobody touches, nobody like maintain it. It's still running after 10 years. And there's like millions of dollars transfer using this platform every second. Still very stable. I cannot do it. It's hard.
That's pretty amazing.
It's very hard, but Bitcoin is very stable, still running, and so far no problem at all. So if you're interested, you're probably gonna read that first. That is a fundamental. It's not easy to read, but once you understand that, you can easily understand the other blockchain products. Yeah. But we are not a blockchain. We are on top of that. We use blockchain. Yeah. It's some similar like you make a cloud application like social media, but you're going to use a database, right? But you are not database. You use database. You save use the information into the database and you get the data back to the application. But you are not database. We are not blockchain, but we use blockchain. And we use a lot from blockchain. Another technology we're using is called IPFS. I'm not sure you heard about that. It's called stand for Interplanet File System. It's a huge topic. It's kind of a storage, like file storage. For example, we try to make it short because I know this is not the main topic for today. Try to make it short. For example, you store a file in your hard drive. So this is a single node. What if someday your hard drive failed? Your computer was stolen by some people. You lost the data, right? Yeah. IPFS is different. There are like 1,000, maybe 10,000 of nodes running in cloud, not cloud, peer-to-peer network. So if you save something to the IPFS network, and there will be nobody know how many machine nodes have the duplicate copy of your data. So as long as one of them still survive after a nuclear attack, for example, as long as one of them survive, the data can get back. That's very robust.
Okay.
So it's called the IPFS. We actually use that a lot, and we're doing the same thing. We're doing the same thing, like we deploy your code and your execution to something like similar to IPFS. So your code, like your application, is running in somewhere we don't know. It's many of them running. Mm-hmm. If there would be a nuclear attack, like half of the machine was destroyed, doesn't matter. As long as one of them, single of them, is still running, your application is still running. It's just like a Bitcoin. For example, Bitcoin, get to the blockchain, the Bitcoin, there are like thousands of machines, much more than millions of machines I can see running Bitcoin algorithm. So even if there is a nuclear attack, like a lot of banks, like for example, what if Canada get attacked, a lot of banks in Montreal or in Toronto get destroyed, so your data destroyed, right? But for Bitcoin, doesn't matter. As long as one single machine is still running, survived from a nuclear attack, your data, your money is still there. And you know what? There are 2 satellites running in the orbit of the Earth. They are running one of the Bitcoin machine. So even if the Earth is totally destroyed and the data is still in the satellite.
So your money's still there even if like everything else is gone.
Yeah, the Earth is blow up.
Yeah.
And the data is still
So
there.
that's like the concept of like decentralization, right? Or
yeah, this movement is called, we call the decentralization movement. So we have everything very strong, very robust. We can nuclear attack proof. That's why we're working on that. But I go back to the topic. I don't want to spend too much time on that.
Right. So maybe like now just tell me like some of like your, like what you feel like are your like successes and like some of your failures like throughout like your years of doing like software development and this kind of stuff.
Oh yeah, of course. Failure is very common. It's very common.
Yeah.
I can tell, I believe you're a developer as well. So when you're working on the project, for example, it takes like 100 days to make one product. It's a very short period of time. Just for example, 100 days. So the 99 day, what you got is failure, right? Only the last day you got is successful, right? So it's very common. So like what we spend most of the time on the development is debug. Why called debug? Because there is a bug, right? Bug means failure. So most of like 99% of the time we are facing is fail. We have to fix the problem. And eventually, if we're lucky enough, we got a successful. That's it. Sometimes we cannot get there. For example, you try a new way to do, we still go back to the fake Facebook, but then Facebook is very successful. But if you try to do something similar, and you're going to try something like you probably don't know right now, you try, how about the people using a video to talk, or how about people using like AI to talk, have some bots to talk to people. You try different things. But I have to say like 99% of this stuff, new trial will die eventually. Only very few of them gonna successful. It's very common. Now, even in Silicon Valley, 97% of product die in 3 years. So only 3% got survive. So it's very common. So if you're working on software industry, it's very common. You can have to face a failure every day.
Right.
It's very common. But I still encourage people doing that because if you don't fail, you don't know what is going to be successful. You have to try. Especially, for example, you are very young, right? You have at least 30 years like me. I have at least 30 years to try. Even you try like 10 times a year, it's very slow, right? 10 times a year is very slow. You have 300 times to try. Based on the 3%, you still have a very high chance to win, right? So why not? Yeah, so it's common.
Yeah. So are there like any ones that are like especially like memorable for you as like you moved throughout your career? Like times where like like, oh okay, so this is something that I definitely did right, and like I know like from experience that the next time I face something like a similar problem, I definitely go with that, and then like I know like it would definitely work out.
Oh yeah, it happens every day. So as a software engineer, the learning is probably the first personality you have to do every day, because the industry grows so fast. You actually cannot like learn something when you were young and you use the same technology or same knowledge for all of the rest of your life. You cannot do that. Probably in other industries, okay, like the hydraulic, probably okay, because the hydraulic technology was there like 1,000 years ago. People still use the same technology invented by Da Yu like 2,000 years ago, still use the technology today. But in the computer industry, like software, especially software industry, it's not possible. New technology was invented every day. You have to learn a lot of new things. So it's very common, like you try to do the same thing with old technology or old methodology. It even doesn't work. Or someone tell me, oh, there is a better way to do that. So you're gonna learn it. You can you can be very productive. So this happens almost every day. So I'm already working on this for almost 30 years. I still learn every day. A lot of new things, especially, for example, the Rust language is one of the new things I learned this year. Because of the pandemic, I cannot go anywhere. I stay home. And so, probably this is the best time to learn something new. So I pick up a new language and learn it. Actually started last year, not this year.
Yeah.
So it's very common. It's very common. And you learn by, not only at school, even if you're a graduate and you work, you will not only work for in a company or for open source project, you still learn. Yeah, that's a lifestyle.
Yeah. Wait, just a quick second. My laptop's dying, so I just gotta plug it in. Really
Okay, go ahead.
My bad.
I got water.
Yeah. Sorry about that.
Wait a second. I get some tea. All right, I'm back. Yeah.
All right.
Go ahead.
Yeah.
By the way, before you got the next question, probably I can tell you something about there will be a lot of mind-blowing moment in your life, career life.
Yeah.
Mind-blowing means you never thought this question can be solved in that kind of new way of thinking. They call them mind blow. So the recent the new concept that blow my mind is, for example, the Bitcoin. I just mentioned the white paper. I remember a few years ago when I first read the white paper. At the beginning, I think it's so boring. At the beginning of the white paper, tells something like a lot of mathematics.
Mm-hmm.
I don't really understand why people do that in such a stupid way. But once I keep reading until it's not very long, just 8 pages of white paper. It's not very long, but the white paper is always something hard to read. It's much harder than the documents. So once I finish the whole page, I have a very strong feeling that, my mind was blown. Because I never think about it, this kind of question can be solved in that different way. And I was thinking, how I can attack the Bitcoin system. I believe there must be something like vulnerabilities. I can find a place to hack into it to modify the ledger, so we can add some money to my account and steal some money from other people's. And I was thinking for a while, and eventually I believe, this guy who invented Bitcoin is really a genius. He has thought of a lot of different way to attack it, to how to hack into it. He tried to already fundamentally change the way how people moving the money from location A to location B. He fundamentally changed this. So after that, I think, I totally agree. I totally believe the blockchain could change the world. At least, for example, the Bitcoin, the financial industry would be changed very soon. So that's why, starting from that moment, I started, probably I'm gonna change my mind from the cloud computing, which is why I was working on cloud computing for more than 10 years. I was started to try to do something. It's not cloud computing, it's a decentralized computing. It's very cool stuff. But it's very hard. I can tell you, everything centralized is very easy, much easier. Like cloud computing is very easy. From my point of view, it's very easy. But decentralization is very hard because you have to handle very complicated situation because it's a distributed system. The network may fail. Some people may be hackers because we have a terminology called the Byzantine fault. Byzantine fault means not a physical network broken or hardware broken. It's Byzantine fault means some people is a bad guy. He tell you something, intentionally tell you something wrong. It's called the Byzantine fault. You have to deal with that. Like in a centralized computing, like cloud computing, you don't have to deal with a Byzantine fault because computer either work or failed, right? It cannot tell you. They try to tell you something wrong. Computer will not do that. But in blockchain, you have to deal with that. Patenting fault is very important. You have to think in almost every day. It's very hard. But anything is too easy, you won't feel any challenge on it. You like to do something that's very, very challenging and say, oh, I can try this. I say, oh, how people make it work? Or always think about it anyway. Oh, probably we do this. Oh, it doesn't work. I try again. Another way. So it's a way of thinking. And once you figure out, aha, this works, and you feel very successful and very, very exciting on it. So that's how people get the mind-blowing moment. And yes, that's how I feel. Probably you like it too.
Yeah. So like for decentralized, does like the conventional sense of like debugging still work? Because like it's like no.
For example, the centralized application, you probably can set a breakpoint somewhere. You can see what's happening inside the machine, right? Because it's centralized, you own it. You can do whatever. But in the distributed or decentralized the situation, you don't own the node. The node is belongs to some people else. You actually cannot like get into the node to set a breakpoint and see what happened there. You cannot. So it's very hard. You have to do using like some kind of protocol. The protocol to test how it's gonna work. And even you have a protocol, it's still very hard to test. So that's why I'm saying, if you work on the distributed or decentralized projects, the hardest part is how you're gonna figure out if something's wrong, how you're gonna figure out why it's wrong. It's very hard. You cannot set breakpoint. Sometimes you cannot see the log either because the log is another people's machine. You probably don't. You cannot. In most cases, you have no access to that machine. So that's why Rust as a language getting popular, very popular right now on the distributed or blockchain world. One of the biggest reason is Rust. Rust language not very fast. Its development is very kind of slow, compiling very slow, but very fast. The fast is not the main feature. I believe the main feature is very stable. It's much stable in any language I used. Like I used C a long time ago, and I know you have to be very careful to handle with the pointer. Mm-hmm. And it can easily cause some we call the buffer overflow, stack overflow, or sometimes you have a memory leak. It's very easy to make if you don't be very careful. In Rust, all those stuff will never happen. So the language actually can help you to track. If you're gonna make anything dangerous, probably you forgot to use the pointer, or you delete the pointer is in use, or you locate the memory and you forgot to delete it. This kind of stuff, the language can handle very well. It has ownership. It has a lot of different borrower check. This doesn't happen in any previous language. So using this kind of language, the Rust language, the possibility to make this kind of low-level mistake is much lower. So some people say if you use a Rust to make a application, you don't need to debug. But I don't know. I know this is not this is incorrect. I know it's incorrect because you still have bug. But I can tell you probably don't have those kind of low-level bug. So all the bug you probably got is probably the logic bug. The logic bug. It's not a mistakenly delete a pointer. You don't have this kind of bug in Rust. So that's why Rust is getting very popular right now, because people know if I made a mistake, almost there's no way to fix it. Very hard.
Yeah. Mm-hmm. So why would you use Rust over like a higher level language, like maybe like Node, JavaScript, or like Python, or like something like that?
In our project, we use 3 languages. One majority, maybe 98% is Rust.
Okay.
Because it's a low level, we're working on the low level, like operating system level. Low level, so probably we cannot use a high level language. That's one reason. And then the second reason is stable, and the way it's very you don't make low level mistake. And second language we use is Golang. Go language. Golang. It's made by Google. We use that for a lot of network traffic because Golang is very good at that. Make the like network traffic. It's perfect on that. We also use JavaScript because we still have some UI, not a lot, but because we still have a UI to, even for us, we test ourselves, so we need some UI. So JavaScript is currently the only language we can use in the UI, so we use JavaScript as well. And even we use Rust, the compile target is not Rust. We compile to a new binary format called WebAssembly. I'm not sure you heard about that or not. So
No.
WebAssembly, it's a newer format.
Okay.
So we use Rust, but when we compile the code, we eventually compile to WebAssembly. WebAssembly is a new format. It's it can run almost everywhere, and it's we're gonna use WebAssembly in our system. So that's how we're gonna work. I know a lot of new terminology. Probably never heard about it. It's totally fine. You will heard about later because we're at the cutting edge. Probably because you're still young, you're probably learning something like people invented 20 years ago. But we are working on the cutting edge, so we're gonna use new terminologies every day.
I'm definitely interested, so I'm gonna look into it. But like right now, so far, what I've been doing is I'm doing like this. I'm building like an e-commerce platform like online right now. So like I just use like Node JavaScript on the back end, and then I used like just like the front end trio thing, like the
React. Oh, you React now. Why don't you use React?
React is better.
What kind of framework are you using?
So I'm building a web app right now. So it's more like HTML, JavaScript, and CSS.
But probably you have to use some kind of a framework. For example, React is one framework. Angular.
Oh wait, React.js, right?
Yeah, React.js. Yeah.
Yeah. I'm gonna look into that one. I've heard it's pretty good, so I'll look into that.
Yeah, there are a few choices. Like React is one of them I was using. There are like a Vue, VUE. It's also very popular. We're using Vue right now. I used React before, but now we tend to use Vue. And also Angular is also very popular. And probably other newer one I didn't know because I didn't work on front end for years, so I don't know. But you have to use one of them. Otherwise, if you hand coding the pure JavaScript, it's pretty headache. I don't really think you like it.
It's been a headache so far.
Yeah, it is. And very few people, especially working on web app, I think very few people currently still using we call them vanilla JavaScript. Vanilla JavaScript means you don't use any framework. You hand-made the coding JavaScript.
Yeah.
I think very few people doing that right now. It's too slow and it's hard. Yeah. So people use React. I use React. I like React so much.
Okay.
You're probably gonna choose one of them.
React and Vue. Okay, I'll check those two out. Yeah, thank you so much.
Vue is easier and newer. Vue is newer, easier.
Yeah.
If you're working on some smaller project, for example, the project is gonna use by very few users, or you want to have a faster pace to try new stuff, Vue could be better choice. But React is React is much better than before. You still have to learn. It's a kind of bigger, like a steeper learning curve for React. But Vue is kind of easier. If you want to go Vue, go ahead. It's easier. React is, if I work on the bigger project, like I know I'm gonna have like 30 people, maybe more working on same project. I probably using React. But if for only one person product, Vue is good enough.
All right.
Yeah, you have to use one of them. You don't do manually. It's hard.
Yeah, I don't think I used JavaScript too much on the front end so far. Like basically, like I just tried to make up for it with like CSS and stuff. So
there's a lot of tools. Like front end, front end world is very, very special. Like there's so many different frameworks that people can choose. There's so many different tools. Even Node.js has so many different versions. JavaScript language itself is so many different versions. Like the ES 2007 something, I don't forgot. JavaScript has different versions. Right now, people tend to use the TypeScript. Did you use TypeScript?
No, I don't think I actually use those. Like
But I encourage you to try TypeScript.
Okay.
The TypeScript actually is a JavaScript. It's a little modified version. The benefit you can get is it introduces the type to JavaScript. JavaScript is like a dynamic language. By default, JavaScript doesn't have type. You actually can give a variable whatever, right? It's a type, typeless. But the TypeScript actually changed a little bit. TypeScript gave the types to the JavaScript, so you can make less mistakes using JavaScript. Probably going to try that. And it's fully compatible with JavaScript.
Mm-hmm.
You can try that.
So far for like JavaScript, I kind of just like took a kind of easier route. I just like used EJS instead of like HTML, so like it's like all embedded in there.
Yeah.
So like I think that took out like a lot of the more annoying aspects of like using like vanilla JavaScript. But like I'll definitely look into like React and Vue and those stuff. Yeah.
I think one of the biggest benefits when using React is two advantages. One is you can think about, you can make a lot of components. You can reusable components using React. So that's why I'm saying if you work on a product like bigger, like for 30 people work together, React could be the better choice because you can spend some time to make some like reusable components that people can reuse. So you make some components that people use their page. So that's one of the benefits. I think a second one is even more important or useful is using React, especially we call a paradigm called Redux. I think they call it Redux. I did use it for 5 years. That is a way, for me, as the first time I learned functional language, functional programming. Functional programming is different than the object-oriented programming or OO programming. It's different. They call it functional. So using React and Redux, it forces you to think in the functional way. So it's very, very important, especially if you're working on software. Eventually, you're going to mix OOP and functional programming. So Redux React is one way to get to know it. And if you understand how Redux works, you probably understand, functional programming is something like that. It's very helpful.
Have you ever used OCaml as a language?
I didn't use that, but I know it. I didn't do it.
I did like some stuff with that, like for a course, basically.
Oh, that's cool.
Like working with like streams and stuff, so like infinite data structures, but it's like the basic stuff though, like nothing complex. Like, cool. Yeah, you're like giving me like so much information. It's like so like amazing. Yeah.
Not surprised. You know, when I was in Canada 10 years ago, I didn't go to Silicon Valley at the moment and talk to my classmate who is in Silicon Valley. We talk about the computing industry, talk about the programming languages, talking about the products. He gave me a lot of new terminology I didn't know. Exactly the same feeling as you have right now. Like, what the guys in Silicon Valley do? They talk in different language, a different kind of animal. What the people in Silicon Valley do is very different. People live in Canada, especially I was living in Victoria, BC, which is like a layback place. People just doing fishing.
Yeah, so, you're taking me to school. You're taking me to school.
Oh yeah. So that's why that's why it's also one of the mind blowing moments. So I think, probably I have to go to Silicon Valley someday. I want to go to the top, the cutting edge. I want to talk to the people using their language. So I came here and I feel I like this place.
Yeah, nice. Okay, so thank you so much for the interview and like all the helpful knowledge I've been given.
Yeah, interesting. I like to talk to you. Especially, I'm very happy you're willing to learn. You're interested in this kind of new stuff. That's very good. So, some advices for a future software engineer. So, learning new stuff is your daily life. You're gonna like it. Yeah. If you don't like it, don't do this. Do something else. All right.
Just like the amazing stuff we can actually build, like with all the stuff we're learning. And it's like in most other like more conventional like careers, you wouldn't really get to start building your own stuff until like you're at a certain level. But here it's like as you're learning like all the amazing stuff, you can just learn it and then build something out of it, and it's just like mind blowing. I don't know.
Exactly. So building something is the only way you can learn it. You actually cannot like learn some other stuff. You can read the books and learning from some reading other people's work. You're gonna know how to do it. Computing computer language, like computer programming, is something different. You have to do it. If you don't do it, you'll never learn. Reading is very easy, but you don't know how to use it. I have to do it.